and also human expert or sniffers or panelists have to be ready and must be trained. It costs a lot and it's very expensive. Another evaluation for grading Agar is scientific evaluation. Normally we use CMS or GCFID and other scientific evaluation. This is, of course, we have to take the samples. For example, this resin, we have to book the time for laboratory. It costs time. It need a very long time to validate or to certify the best quality resin. And they also grade Agar based on weight and many other methods. However, this is the problem statement. All detection or identification, classification need a very long time. This is the problem statement and very costly. So this is the how our INOS is started. Okay, and market of Agar is around USD 6 to 12 billion yearly. And other problem statement for chemical, oil, and gas industries, I just pick up 3 problems. In Malaysia, we have ammonia leak at us factories. Yeah, this is very harmful to human, and also gas tank blast at Kuching Mall. 3 dead, 41 injured, and also hazardous gas in Pasir Gudang, which is they have to do more research, use many devices in order to identify where is the location, the point source of the leakage. This is some examples. The issue is in cater to countermeasure to take the action of this problem is it's not only expensive, but also we need foreign specialist or detector or device offered into the market, which is mostly on only covering sometimes on single gas detection. We have many devices. Then we'll discuss this device after this. Okay, this is some of the problem from chemical. We cannot detect simply. Okay, this is the many community or industry complain about the odor, but they could not quantify the odor. This is some of toxic gases with odor industries. The famous ones, ammonia, right? Ammonia, hydrogen chloride, okay, until methyl. Then you can see here the toxic gases, which is commonly found in industries, chemical industries. Some, but by no means all detectable by odor. We can detect the odor, which can serve as warning, but the odor cannot be explained in terms of cannot be explained quantitatively. We cannot measure, cannot produce the number. This is the problem. Okay, some direct effects of toxic gases you can see here. It will attack visual system, central, auditory, respiratory, skin, heart. This is the early warning. We know the odor, but sometimes they call these gases or compounds or volatile organic compound odorless. Sometimes INOS not only sense the odorants, but also odorless, which cannot smell by human. It can go to that extent for INOS. Okay, then what's our offer, our solution? This is the Symbion. We try to offer our core technology. Our sensor offers first is on-site detection. So meaning no need to bring the sample to the lab each time we want to detect. So we can bring, it is mobile. For example, this is the INOS that we brought to India last year. Okay, we want to detect whether the resin is the quality of resin, or is the resin already can be harvested or not. So directly we put the INOS here, we hit the tree, and then the smoke will come out from the tree, and then we sense from we have the library from the we have installed the library into the INOS, and then we can see whether it's similar to the library that we have. And we did this for several species, several trees, and of course there is a measurement, there is data. We can, at least we can sense whether there's a resin or not. Okay. And then INOS is the reliability of the result is okay. It's supported with scientific data from GCMS. Actually, our INOS is a combination of three experts. First, from chemists. Second, from electronic, and the third one is the panelists. Okay, and then the INOS is not only electronic device, but it also come first to ensure, to validate whether the sample is how the odor is coming from which compounds. We have to validate with GCMS, the chemistry, with chemists, and then the sample by the experts. For example, the experts in Agar need 20 to 30 years to analyze and to familiar with the odor, and then the sample that the expert and analyze or detect will be validated by GCMS from the scientific data, and then after confirm, we take the data using the INOS, and that one will be the library to our INOS. This is how INOS is working. We need these three experts. It's actually complementary, and then the result is of course rapid and instant. It's not no need to wait one week to 3 weeks or 1 month. We can do it within several hours, maybe less than several hours. We already have our own AI, artificial intelligence. This is case-based reasoning, based on case. This is what I call, this is our core technology, the case-based reasoning. Many INOS in market, but they leave the option to clients to choose. Meaning client have to analyze. But for us, in Unphone, we ready with case-based reasoning. We shorten the time of analysis, and we can have the library very rapid. Instant result. For example, for Agar, grading of Agar, and then our in-Unphone also is a platform technology not only for Agar, but is applicable for many industries, and offers the fixed one. We offer IoT solution yet right now, but for fixed, we offer IoT solution for online or offline monitoring, and of course, Unphone is mimicking the function of human nose for industry application. Okay, this is the INOS is a custom business model and deliverable for clients to meet each client's needs. Exportable, proven high impact local technology with some track records. Cheaper solutions, and combine hazardous gases, odor compounds, and detectors. Okay, so maybe participants from industries or university have some issues, some odor issues at your place. Maybe we can solve, or we can analyze the problem. Maybe INOS, Unphone, one of the solution. This is I want to compare how INOS works. We have we compare with the nose, biological nose, and also electronic nose. Okay, if we see here, either biological nose or electric nose comprises of four main parts. The first one is receptors for biological nose, and nose replace the receptors with sensor array. Sensor array, no, you can have many sensor array, maybe 3, 4, multi-sensor array, depends on application. We have olfactory bulb in biological nose, and of course here for electronic nose, we process the signal, extract the features for biological nose, either human or animals. We have olfactory bulb to analyze the signal, and we have brain memory for biological nose. We have memory as well, but in terms of microcontroller, okay, microcontroller, SD card, whatever, cloud. And then the last one is the brain. So our brain is CBR. Our artificial intelligence is the case-based reasoning. So this is research has been done for many years from scientists. This is the output. Of course, what's different between our INOS and other INOS is actually the intelligent classification technique, which is case-based reasoning. Case-based reasoning actually experience from past learning, and then we adapt the past learning, the experience, and we install the case into the library. For example, we have many library. Then if we compare the unknown case, for example, we want to detect the unknown case based on library, the existing library that we have. The CBR or intelligent classifier can match, can compare whether the unknown source is matched with the library installed in the. If matched, then detected. If not matched, then we will assume this is the new case. And this is the case, and we increase the library with the new case. Whenever we found any case, unknown case or existing case, same with the library, then this is the how our AI works. So of course, biological nose depends on our is not standardized. For example, we in Malaysia, for example, Allah create our nose, right, different from people from France, from Arab, sensitivity. Also, how to standardize? We come up with solution with the electronic nose, which is scientific solution. Okay, this is the competitive advantage. Okay, if this the elements to compare, we can go from application, features, price, disadvantages and also advantages. Okay, here I show you three types of. We want to compare in unfold sensor with Cynos sensor is also established in UK. I also used this one previously 10 years ago, and we have also human nose or sniffers. We call it or panelists. Okay, panelists. Okay, here we can see that our in unfold we have two types, fixed and also mobile. Our INOS is a in unfold is platform technology, not limited to one only. Diverse application for quality assessment. And of course, for Cynos sensor, normally you can use for, but it's dedicated to only one Odour. I experienced use this sensor previously. Normally, we have to put in laboratory, but we have to analyze. We cannot use they have methods, but it's not customizable lah. It's not customizable. Okay, for human nose, of course, we depends on experts. We don't know. We cannot. Of course, we cannot identify whether the human expert is how about their integrity, right? We totally depends on sniffers, but we don't know whether they are correct or wrong. This is some features we have for e-unphone. We need less analysis to extract odor, and of course for Cyronos, of analysis. And then for expert, depending on training and competency, accuracy and integrity is highly questionable. This is the problem. Our cost is around per unit. It is 25 to 32K. Then for Cyronos, it's a 36 to 250 range, from about 100 to 160 all samples per day. Very specific in detecting based on libraries developed, thus will not detecting other smells. And for Cyronos, detecting other variables as well that will influence the result. Portable but not applicable for in situ analysis. Limited to certain experimental conditions and high maintenance cost. And of course, for human analysis is prone to human errors. For one single data is okay, but for many data, then it's subject to a questionable result. And for advantages, we have, of course, reliable data library. For example, for Agar, Odour, portable, enabling in situ implanted. And we have for Cyronos, it has GCMS analysis, oil-based, and for humans, trusted experts not acknowledged by Agar industry. This is the good for sniffers, most commonly used in Agar industries. This is the I forget to quote. This is from journal, the information from journal. The differences between olfactometry, other sensory methods, and also electronic nose, and also GCO. Okay, I want to highlight 3 points here. The first one is quantitative measurement, quantitative measurement, odor concentration. If we look, and then the second one is continuous measurement, and the last one is the cost. Okay, if you go to these 3 features, olfactometry and GCO, electronic nose, can be quantifiable. Can be quantifiable. And two aspects from eNose. It can continuously measure the odor. How about others still cannot continuous measure? Okay, like olfactometry, sensorimeter, and GCO, they cannot continuously measure. The odor cannot be measured using this method. And of course, the cost. If you go for eNose, the cost will be reduced. Can be reduced. This is the good from the eNose. Even though we have some common issues in eNose, which is the measurement standardization. Because normally eNose based on specific application, and this is the challenge to the eNose. But still, eNose for cost, if you're talking about cost or identifiable, still eNose can beat other methods. Okay, this is some market potential that we studied. Several market potential can be explored, like health and safety, agriculture sectors, food quality control, oil and gas industries, environmental monitoring, and also automotive sectors. For example, in agriculture, we already shows you the examples from Agar. Health and safety, early detection warning system in chemical laboratory. We did this in one hospital in Kuantan to identify the concentration, to differentiate the concentration of formaldehyde in some laboratory room. They want to install the ventilator, but of course they need data to prove to management. So we did this for community service, and then after that we proved that there is a different variation when they use formaldehyde and without using the formaldehyde. So lastly, finally, management approved to install the ventilator in the chemical laboratory room. So this is for health and safety. It's important. And then for quality, of course, we do many solution to the problem. For example, fish freshness, quality of cooking oil. We are working with Zainudin right now, frying oil, to detect the different grades. And then environmental monitoring also, we do the landfill monitoring, and I will show you the example afterwards. Okay, this is some of market potential, like Agar quality treatment, oil and gas. Okay, this is the how market potential of INOS. Okay, if you see here, very expensive, very sorry, the market is very huge. 400 per dollar, very demanding. For honey, for example, we did honey quality classification. Also, we did this one. Water treatment, we previously, before MCO, before PKP, we did present to SPAN, Suruhanjaya Pengurusan Air Negara, SPAN, to detect odor smell from the water treatment, from the water source. Okay, we did present to SPAN, and they agreed. Just waiting for the letter. And then oil and gas. We have oil and gas market, palm oil, many. So this is a achievement that I want to share. Okay, some grant from platform, Malaysia platform, about 700K, and we win Malaysian commercialization year 2019 last year. Okay, grant award. Then Liver Nest Singapore Special Award, and also we have already patented 2 patents regarding the agar wood and also apparatus of agar wood. Okay, and then among of our secured deals, Ajmal Perfumes, Assam, India. Okay, we did this project. We collaborate and we went to India. They need their interest with our Odour in phone sensor for agar wood, essential oil, perfume, and others. Okay, and some W oil already, W oil Thailand, and some W plantation research. Also Odour sensor for environmental monitoring, freshness and quality of cooking oil. And now Zapsi, our collaborator Zainudin, Xylene dispersion monitoring. We did this one. Unimas also for Odour sensing of freshwater fishes waste. And Cocoa Board also interested in grading the cocoa quality. And new collaboration, Royal Malaysia Police regarding drug sensing, SPAN, prawn, and many others. Okay, this is our business partners. Okay, here. Okay, what is our business model? You can go here. Okay, the main one is of course we sell the unit, the sensor, but we also offer rental, customized application, maintenance services, quality analysis report. Valuation report and our business model. It's not only selling but also rental services and consultancy. This is our client, Agar water treatment. Okay. Okay. I want to show some of our project delivered. This is SMW oil, soybean, odor detection and monitoring Thailand. What is the problem? Actually, the problem is 4 to 5 years ago, about 6 years. Okay, the SMW brought this factory from Thailand owner. Then before operate this factory is guaranteed by the government not to be operated. So that's why surrounding this factory, there's a community which is housing, domestic housing. So there's a neighborhood here that they stay. So they complain about the odor coming out from the factory. And this factory has many plants, and SMW oil cannot identify which odor, which point source from the plant directly go to the neighbors. So they did research using 8 to 16 sniffers. They trained about 3 years, but they cannot find the solution. They cannot identify. How? Cannot quantify. They cannot present to their customer. So when we introduced to this problem, we already went there for 2 times. First stage, we do the we take the baseline odor data for 3 days. For 3 days in 3 times a day, meaning about 9 times, many points. And then second stage, we go there to validate our data, and finally we come out with the report. And lastly, we could identify the source coming from which plant. The complaint from the neighborhood. They complain that the odor coming from, but they cannot prove. So now we can prove that the similarity of the odor data is similar to the complaint by the neighbor by using our INOS. And this one of the solution, they use web scrubber and the ozonizer. They want to buy this. If not using our INOS, they have to relay out the plant. Cost about million. With our solution, they can identify the odor, the source, so they reduce the price. Just use this web scrubber. No need to invest million of Thailand million of money to invest. So this is our real project in one of the success project. So they need but now it's a PKP, so we cannot be. Suppose we go there last March, but maybe it will be extended the project. So this is a project of research, SMW research. Okay, we want to identify frying oil grade, cooking oil, best quality oil, maybe from soybean and also from palm oil. This is the amount of the project.
Dr. Shafi,
this is
Dr. Shafi.
Yes.
About 3 minutes extra more.
Okay, going to finish. Okay, this is the grading. We went to India, and this is Mr. This is the CEO, general, GM of the we did with him together about 3 to 5 days to grade, compare with the sniffers and also our INOS. And this is research lab Odour source collaborated with ZAPSI. They have maybe Zainudin will explain more on this. But this is how to identify the xylene that is spread around their labs. They have this is a very interesting project to be presented. And also Jabatan they give some samples. They want to identify different brand of petrol gases, so they cannot identify. This is about some cases in Jabatan Kimia. So we do a test and presentation to identify, and we show there's a variation in different brand of petrol. Okay, petrol and cocoa. See, this many samples of cocoa. Cocoa actually is sensory unit, sensory team, but the sensory need 2 to 3 months. It's very long time. So they need this INOS to grade their cocoa based on Odour, okay, lembaga cocoa. And this is some letter of intent from different industries. We have Satuan Usahawan Madu Kelulut Pahang, then Rural Asset Tridom about the Agar. That's all for me. Thank you for your attention. Okay, thank you.
Okay, thank you very much, Dr. Shafi. Maybe there are some questions already have from Mr. Nelson and Dr. Sam from DOSH. So can we answer by the end of both sessions? So we reserve first, and then we proceed to IR Zainudin first. Okay, the floor is yours, Zainudin.
Hi, hello. Assalamualaikum warahmatullahi taala wabarakatuh. Can you guys see me? Am I? Boleh nampak saya? Yeah, can you see me?
Boleh.
Suara jelas ya?
Jelas.
Oh, sini tak boleh nak share, nak like kat sini lah. You cannot give the like.
Boleh buat nota bawah.
Alright, okay, good. Thank you for UMP Consultancy and Training for arranging this webinar, this live webinar. And thank you, Dr. Shafi, for being the first speaker. And I can see around 37 participants, and we are actually more coming in. Just hi to everybody. Thank you for attending this seminar. Okay, I'm an engineer Zainudin Abu Bakar. I'm from ZAPSI Industrial Ventilation Sdn Bhd. We actually based in Kemaman, Terengganu, but we serve mostly in the oil and gas industries at the earlier stage. But now, since we have some, current oil issues, everything, we actually find out that we can serve more actually to other industries like automotive industries, palm oil industries, education industries, and as well as water making. And recently we did some consultation job for healthcare industries. Okay, we have issues here actually. After 23 years being serving the industry, especially in the industrial ventilation, air conditioning, air pollution control systems, we have been consulting for actually more than 1,000 companies, and we have inspected more than 2,000 local exhaust ventilation systems, and from various industries. We actually have issues, especially in the indoor air quality, on how to quantitatively prove to the client on our claim. Approval, but top management always ask, and they it's not that what you call the company doesn't have money, but is you fail to convince the boss. So that's what happened. So yeah, so we actually come up in contact with Cik Zainudin, my friend was in Kaneka. So Alhamdulillah, so we can collaborate now. So he actually the in charge person for this subsidiary company of UMP. So he can introduce me this e-inform, the electronic nose, which I think is very awesome device, awesome tools to actually solve my problem. Solving my problem is solving my client's problem. So I actually engage e-inform on our own cost actually, and the customer actually would like to have it numerically presented. So we did a project. So what I'm going to explain in this my sharing today is the case study that I have conducted in one of the hospital university, and how we have actually numerically solved these issues, and we can come up with proper proven to the client. So I will share my screen here. Okay, can you see my screen? Hello?
Cannot see, Cannot see.
Tak ada lagi, tak ada.
Ada tak?
Nampak muka handsome Encik Din je.
Tak ada slide.
Yeah.
Tak ada. Belum.
Belum ada
Tak ada Cik Din.
Tak ada
Sekali lagi share.
Sekali lagi.
Oh, Cik Aziz ada
Ada.
Ada.
Dia sebut nama.
Nampak tak?
Okey, dapat.
Nampak.
Right.
Nampak lah.
Okay.
Cik Kamal pun ada.
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 Okay,
muka
now
lah.
application of electronic nose or e-inform. Inform ni an Arabic words for hidung for the nose. In HVAC and industrial ventilation system, a case study. So the objective of my presentation is on the actually to explain the how I apply e-inform in my consultation projects, and the benefits which I think will benefit the industry, and case study. I will share to you the case study without mentioning the actual place and the result, and how I implement the study to for the benefits of the industry. Okay, I've been in industry for 23 years in the field of mechanical ventilation, air conditioning, and ventilation system. I'm a chartered professional engineer.
Sorry. Besarkan slide.
Slide. Is that okay?
Okay.
Yes.
Okay, good. So our expertise actually I lead a team of we have now 45 staff of engineers and technologists to provide a specialized consultancy and engineering services in the field of HVAC, heating, ventilation, and conditioning industrial ventilation system. We ensure clients compliance to the local regulations. For example, use 2000, this one under OSHA 1994, Clean Air Regulation 2014, ICOP 2010, and Factory Machinery Act 1970s, and also the latest clean working in confined space, ICOP 2010, a new regulation by DOSH. And also we care for worker safety and health to make sure they didn't inhale the chemicals. And we ensure the design system is operationally compliant to recommended standards. So these are some of the pictures. We are doing the design. These are my staff doing the consultation. This is what I do. We are computer person, hygiene tech 2, industrial hygiene division. So I'm a competent person as well. Hygiene tech. We have another 2 competent person in the company. So we also do trainings for staff. We go onshore and offshore. For example, on the top hand side, the orange color, these are from Lundin platform at offshore. We did a project for them, redesign of the system. And at the bottom left hand side is Perodua in Rawang. And Alhamdulillah, we have actually opened a branch in Rawang. So to conduct the project, we estimated around 3 to 4 years punya project. So and also the training lah. Okay, these are few examples of projects we had done for the past years. Local exhaust ventilation, air pollution control systems, and also registration with the Department of Environment to get written notification and written approval. I believe there are people here from environmental division, right?
Yeah.
Ada orang tak
Ya.
ni? Cuba check sikit, nampak ada tak?
Ada, kawan
Ya.
ada, kamu ada.
Allah, Cik Aziz.
Ah.
Tuan-tuan.
Baik.
Okay. Alright. Now, I will explain the need for compliance to local regulations because regulations we have to comply anyway, regardless. Once you want to operate the company to the process plan, you need to comply with the regulation. And then how it knows application in the industry, and I will present a case on the HVAC and general ventilation for a laboratory combination with office. So let me explain a bit before I go through, because it will, this term will be quite extensively used. This heating, ventilation, air conditioning is a HVAC. And local exhaust ventilation is governed by US 2000 under OSHA 1994, which is to capture or remove contaminant at their source. And we have also the APCS, air pollution control system, which is to actually capture a contaminant under DOE. So this is requirement under DOE. So for example, just show you very simple, very quick, this one on this, for this space, right? So we have contaminant released in the environment. For actually some of the contaminants, we cannot identify the source. So actually spread about, for example, in the aeronautical airline industry, fabrication of the components of body, aeroplane like Airbus and like Airbus industry, they actually use extensively on the you call it on kabo gum, hisap gum. So it's actually very dangerous. So there are lots of hazardous chemicals inside that. So we actually introduce air supply, fresh air supply, controlled air supply into the room with proper exchange per hour to dilute the contaminant. But have been in the industry, I cannot actually quantify exactly you cannot even quantify the value. Okay. Okay. Let's see about this. Okay. These are the regulations. So industrial code of practice. This one under ICOP 2010. Actually, there are physical parameters, chemical parameters, and biological parameters. For chemical parameters, you can see carbon monoxide 10 ppm, formaldehyde 0.1 ppm, respirable particulate 0.1 milligram per meter cube, TVOC 3 ppm, CO2 ceiling level 1000 ppm. So these figures are actually measurables by existing conventional measuring instruments. But then the reading, let's say for example, in our case for TVOC, TVOC actually contains of is called total volatile organic compounds. There are many airborne type TVOCs. For example, Xylene, from even the formaldehyde as well, benzene, toluene. But we actually cannot quantify exactly what are these forms. So sometimes they have bad smell, but they cannot quantify what is the actual culprit which contribute to the smell itself. So this is issues. When we do indoor air quality assessment as a competent person, I'm not yet a competent person, but I understand that once we have clinical values, let's say of to go drill, to detail, what is actually contributing to the most contributing VOC. So this will be a good approach to using the EAN form. And then this Factory Machinery Act 1970 Regulation 25, where this one in the industry is famous, not less than 10% for process which generate little heat or no smoke or fume. And then you have to have 20 exchange, and then 30 exchange for process which generate chemical fumes. These actually, let's say, even though, let's say for Shell standard, actually they are using only 6 exchange, but our government in this FMA using 10, which is actually very extensive. You have to spend a lot of money actually to design a good ventilation system to dilute the system. What if we can identify prior to the installation, during the consultation, what are the contaminants actually involved, and then we can pinpoint, and then we repair, maybe it's leak, we repair the leak, everything, then we reduce the concentration, and actually, we actually can save money in the future. This is also ICOP for cooperative for safe working in the confined space. This one for the industry. So section 8.6.5, it requires when people working in the confined space, you require actually essential instrument for atmospheric testing with direct reading, calibrated, suitable for measurement. So this has to be continuously tested throughout the occupancy. So once you before this, the normal testing is to go in, the AGT, we go in and measure the oxygen content. And also they have to bring in other equipments. For example, if you want to measure the ammonia or the mercury, so you have to bring in all those sorts of equipments. With EAN foam, actually you can have one equipment that can measure all this. So it's actually real-time measurement, and we can give a quick reading. So even at the lowest concentration, we can quickly identify. That's why I think it's very good for this confined space environment application. You can see here 8.7 ventilation requirement continuously provide throughout occupancy. Sepanjang masa bekerja dalam confined space, you need to eliminating the hazardous atmosphere. You can do this by installing EN foam inside the confined space area, as well as at the air intake. You need to bring in the air, clean and treated air, and actually carefully monitor the contaminant inside the air you bring in. If you didn't monitor, you don't have a very reliable equipment, then what will happen? Everything will die. Selamat Hari Raya kat dalam tu. So we actually also ventilate the area continuously, supply air from clean source. These are all the requirements industrial ICOP for confined space. So actually it's really helpful in the industry. So, and also this APCS from the DOE for Environmental Quality Act 1974. Regulation 7, we have to comply, air pollution control system. For this one, like as Dr. Shafi said, the one in the Thailand, right? At Thailand, they actually save a lot of millions of dollars just by identifying the culprit. What actually caused the smell issues to the surroundings people. So by pre-assessing the environment, then they can identify precisely what are the source of contaminant, then make repair on that system, and then we improve a lot to pay and to build up the system, which sometimes you cannot find in Malaysia. You have to find from overseas, and it costs millions. So as well as regulation 9 on the performance monitoring, this one on the DOE, which I think might not, we need to get a DOE approval, because the way ENFORM measure is not similar to what current requirement by DOE, which I think need to be improved on the ENFORM. Okay, I will go very quick now. For ventilation application, on this area, I believe we have chemical labs, process workroom, underground construction, confined space, columns, storage warehouse, assembly halls, pantry, and offices. Yeah, especially office associated with the library, associated with the process chemical. Okay, what INOS can do, according to my opinion, we can identify precisely the type of chemical fume. So when we have smell, and what is it? Then we can precisely identify by ENFORM. We can identify the percentage of mixing of components, because smells sometimes coming from a few sources, maybe 5 to 6 sources. So we can know what is the highest contributor to the odor issue, and it enables traceability of flow path. When we can trace where it starts point and where it goes, end up at what point. So along the way, we can, if we want to eliminate we can do the proper solution, and then we can identify the broad spread of chemical fume. Let's say a fume, when we're using normal, let's say formaldehyde meter, it can give you some values. But using this ENFORM, at all space, all corners, all the dead space, where in still air, you still can measure the difference of percentage, difference of proximity. Okay, and we can actually enable the pinpoint, the leakage point. This is what I really love about this ENFORM. And then we can apply this to eliminate the flow path, which is causing problem, eliminate the leakage, correct existing defective design. We have actually system in place for the past 10, 15, 20 years. So we can actually detect these issues. We can actually reduce the number of change, thus save your electricity bills, and improve the indoor air quality, and optimize the air pollution control system design. So these are the advantages which I think we can have in the industry. So with the end of mind benefit, we actually can comply to the regulation. We no more complaints from the local people, because we actually tackle the problem at the root cause. Am I talking too fast? Okay. And then number 3 is the compliance, indoor air quality for better health for people, correct system operation, tidak ada no bypass for the system. Okay, this one maybe need to explain further. Okay. No bypass means sometimes in the HVAC industry, air conditioning, or the exhaust ventilation system, when you have, let's say, a few fume hoods and few capture hoods, sometimes you have additional process, then you just step in, and actually it lowers down the overall performance of the system. So actually, by measuring the uncaptured contaminants, then you actually cannot do that bypass. Okay, equipment can last longer. Because this one, especially for acidic environment, I have experience with one company. They have ducting. Normally replace every half year, so replace the ducting. Actually, because of inside there contaminants of acid contaminant, very corrosive. So they have to replace the ducting every 6 months. So, and then energy saving from less air change per hour, and this one equipment would last longer due to acid smell. We have experienced one laboratory. We have small. The lab is contaminated with perchloric acid, where you can see even the plug, the 3-pin plug, and the computers equipment, the IC cards, especially metal and aluminium based material become pitted, become whitey colors, and then actually corrosive, become oxidized. Yes, oxidized. So we can detect as well. So okay, that's the ini. I would like to share this problem at case study. We have actually complaints of unpleasant chemical smell. Maybe VOC. They suspected of Xylene inside office room located at first floor. Actually, this building is a laboratory combined with the officers, the researchers officers, master students, PhD students. They are staying there, but they're complaining about the smell chemical, which actually this chemical actually located on the other side of the same floor, the building, and also at the ground floor. So how come there's no chemical activities inside the room? Then they can smell such a, and then they keep quarreling to each other. They keep blaming each other, and therefore, for the past 10, I think, for the more than 10 years, they have been quarreling about who actually caused the problem. So there's no firm evidence on this claim, right? So we went to investigate the actual source of chemical inside the office. Then we propose design and build a suitable engineering control solution. Okay, I would like to share this figure. This is the building. Can you see this, my drawing here?
No drawing.
No drawing.
Apa mu gelak ni?
Yeah?
Cak-cak tu, Saudin.
Oh. Nampak tak?
Tak ada bang.
Tak ada.
Ada
Kalau
Tak
buka
ada,
ni
bang.
kena close.
Kena close yang ni dulu.
Dan buka isometric.
Okay. Sekejap
Tak gambar Cik Aziz keluar ni.
Demo buka gambar kawan tak dapat. Work from home je. Bila masa so office ni bang.
Tengok gambar sikit. Buka gambar sikit.
Apa serabut ni? Tak ada. Gambar Saudin je. Gambar Saudin besar.
Boleh ni?
Kena install.
Install petang garang pula lah.
Yang ni nampak tak? This one.
Pun tak nampak ni.
Tak nampak bang.
Oh, okay.
Ada.
Actually dah buka awal lah. Pun tak nampak sorry
Pun tak nampak ni.
Nampak saya pun tak faham. Baru first time pakai Zoom ni.
About 5 minutes more.
Nampak.
Apa take 5?
5 minutes more.
5 minit more. Ingat take 5 hari ding.
Nampak tak sekarang ni?
Tak ada ding. Tak ada.
Kena tutup dulu yang tadi tu.
Tutup dulu. Unshare dulu.
Share tu.
Unshare dulu, lepas tu share balik. Tutup PowerPoint tadi.
Bismillah.
Sekarang nampak tak? Tak eh?
Tak apa deh.
Oh,
share.
Apa
Ya,
cerita je ni? Muka tak berubah je dia.
Sekejap Aku dah
sama.
gabra ni. Tak ada keluar
Sama.
ni.
Sama macam Eperan dulu lah.
Kau jaga molding dulu kan?
Betul. Ganti wasan.
Ganti wasan. Wasan Trajan.
Wasan Trajan. Kamal ke tu?
Kamal lah tu.
Allahu Akbar. Kenal suara dia.
Macam mana boleh tak kenal?
Kenal.
Kenal belaka dalam ni.
Mana begini?
Tak apa deh. Proceed dengan yang apa yang ada lah sebab next ni kita buat Q&A. Ada few question.
Okay. Nampak tak?
Apa?
Tak ada.
Allah.
Green screen. Dia nampak.
Ada
Tadi nampak.
Tadi sebelum tu.
Tadi nampak dia.
Sekarang ada tak?
Tak, ni PowerPoint tadi. Yang ni PowerPoint.
Tadi. Folder gambar tadi.
Folder tadi, ada satu folder tu.
Buka folder tu je.
Ya.
Nampak.
Nampak
Okey. Baru.
Selamat. Tak malu orang kampung.
Tak malu.
Ni ground floor bangunan ni. Actually ni drawing yang kita hasilkan lah. Drawing ni 3D drawing yang Zapsi hasilkan lah daripada kita main Rahman. Okey, kita tengok kat bawah ni ada testing untuk Xylene lah. So dia ada exhaust system yang tarik ke atas. Office yang kata tu dia duduk tingkat-tingkat atas. First floor. Yang ni nampak tak?
Nampak.
Okey. Kalau kita tengok kalau kita tengok floor plan ni, ni tingkat 1. Kita ada kombinasi museum, office, research office, meeting room. Kemudian actually kita ada juga makmal. Dekat tingkat 1 ni. Tadi tingkat bawah ada chemical testing, ada LEV. Kat bawah ni dekat sini ada Xylene testing. Tapi yang berbaunya dekat sebelah sini. So kalau kita tengok jarak dia memang jauh. Kemudian kita ada juga bilik dekat belakang ni, bilik neurologi dengan bilik diseksi ni tempat is a room for body punya cutting lah, mayat tu buat body. So kat sini actually this one we call air conditioning and general ventilation, and we can see here a written air grill, which is actually not correct for this application. We actually recycling the let's say formaldehyde in this area, and actually we have a big air conditioning system, 10,000 around 700 CFM. We serve with this blue line to the all floors area, and this red line actually extracting the return air and also fresh air coming from this side. You can see here there is no return air from the laboratory. So but how come the smell coming from here? Actually we become hypothesis on how this one actually being extracted by this return air line. And also it's not possible for the one with from the ground floor we enter the first floor. Yeah, so boleh nampak report ni? Can you see this report?
Boleh
Okay.
Din.
Okay, now I will show you this report, how we did this testing, engaging Dr. Shafi for the testing. We want to investigate this issue. We want to quantify the source of contaminant. So this is the way the report is presented. So so these are the points. We do the testing. This 1.01, 0.02 is the source area where the pouring process of the xylene and investigation at some suspected areas, complaints area from PO3, PO4, PO5, PO6, 7, 8, until the first floor, and at this walkway where you have the exhaust contaminant from LEV systems. So, and the final point is P010, 08. This one actually you can see the nose actually sniffing directly inside the container of xylene. So it's very interesting that you can see from this result actually. I would like to share this. Okay, this is the percentage of xylene proximity distance. Means at 0.01, which is also as R1. This one by statistic analysis method done by Dr. Shafi. Actually, we want to measure the xylene proximity distance. Mana how close is the measurement at the sampling area related to the source. So we can see here from PO1, R10, R18 is the source, right? 1 is totally not the same, 10 is close. You can see this value at this diagonal is 10, means P01, R1 is the same at the same value. You can see here at 0.01 is almost similar to R18, which is the source. So 9 is almost close to 10, about 92% similarities. So I can, this one exactly, of course, is because it's the pouring station. So exactly the same. And then we have P08. P08, we can find the similarities near to the source. P08 actually is the laboratory externally of the library of the lab. And then we can have another. We have here 13 and 14. Very surprisingly, P13 and P14 actually is this area. 12, 13 here. Actually, at the first floor, at the lab, walking around, we can smell. So it's very interesting. And we didn't actually realize on that beforehand. So, and then we have P17 and P17, which is another area. So by this identification, near similarities to the source, we can actually extract the following. For example, the travel pathway from ground floor, from fume hood at the ground floor to the first floor walkway. these possible causes of the unsealed LEV sampling point. As you can see, the sampling point is made from normal aluminium sticker. Normal aluminium sticker, which is non-standard to DOSH requirement, which to use neoprene plug, proper seal, so there will be no leakage. So VOC is highly volatile. So let's say after this, you as a owner of the system, LEV competent person, they should use a proper sealing neoprene plug for the LEV system. Otherwise, you will get the contaminant actually exposed out. Okay, and then we actually also identify the carbon filter is not efficient. Actually, has not been changed for the past since operationing. Then I don't know. They haven't changed the carbon filter. And then for immediate action, we seal the sampling point, and permanent action, we prepare it as a minus pressure. That one, actually, we relocate the fan, so that currently is after fan, so it's positive pressure, but we make it to, we move the fan at the higher, so that that area become negative pressure line, so there will be no exhaust out, even though it's improper sealing, improper seal, but it's still no chemical will go out. We go out of the LEV system, so it's good. And then carbon filter, we found out that carbon filter hasn't been changed, and the system is not serviceable. We have to open everything, that thing, and then there's no door for maintenance. So we actually design a proper dust, proper filter box using carbon filter, and with proper calculation with the correct amount of carbon inside the filter box, then we solve the problem. So we replace the carbon box and upgrade the efficiency. And then the travel pathway from first floor lab onto the other side of the first floor, actually it comes from it actually seep out, exfiltrate out from the lab, especially when you off the LEV, then there's still fume inside there. We actually migrate to the corridor area, and then being sucked into the aircon, and then supply to the entire floor. But this one happen intermittently, only if the LEV not off. So that's why sometimes you can notice, sometimes you didn't notice the smell. So we found that the LEV system is inefficient, especially if but the system actually not capture contaminant effectively, and we redesigned the LEV system. And the general ventilation, actually we have this issue here. The laboratory pressure negative compared to the corridor. So the laboratory compared to the office, the building pressure have to be negative compared to the office, so that no contaminant will enter the room. So the design actually has to be improved in terms of SOP, and if possible, I want to show again this result. Semua orang boleh nampak table ni, this table? Boleh? Nampak tak table?
Boleh.
Hello? Boleh?
Boleh.
Ada?
Ada.
Okay. You can see one is very that is close proximity, and you can see this area, There are also at other places, 7.5, 8 here, 9 here, 6 at other areas, and also these small values. What does actually means? Anybody can respond?
Semua mute semua ni.
Oh, okay. Actually, we detected something very interesting. That almost the whole area actually detected with xylene, but in very little percentage. It's like the whole building, the people there is living in the xylene airborne area. There is insufficient air to dilute the contaminant. So this is very interesting. So what we cannot do the immediate action, but actually we have to redesign the proper fresh air intake for proper dilution. Then it's not sufficient. We maybe need to upgrade the aircon system. So we need to actual proper balancing. So
Then can I ask you something then?
yeah.
Looking from the initial punya finding tadi kan, is it poor maintenance or poor PM included in this your finding also?
Yeah. This one?
Yes. Carbon filter not change. Then I'm not sure. The earlier stage it might be not the design, but after that might be the PM, the overall system of it. Part of it lah.
This term non-serviceable, the carbon filter is placed inside a box without access. So you need to open up the whole that thing to bring down and open, which is design wise is shouldn't be there in the first place. So you cannot even service the filter. You cannot even take out the filter. So this is where the proper maintenance, easy maintenance mindset have to come in at the earliest stage of the design. So
yes, I agree with that.
Yeah, that's it. Thank you for the thing. Actually, I'm at my end slide just now.
Okay, proceed.
Maybe I leave to Cik Zainudin for questions.
Okay, thank you very much all the participant. Sabar menunggu question to wait until end of the session actually. So we have a few questions. I read from number 1 and a few questions from Cik Kamal, Mr. Nelson Ng, Vivo 1920, not sure what his name actually. And then from Dr. Sam from DOSH also. Can I proceed, Dr. Dane and Dr. Shafi and IR Dane?
Yeah.
Okay. Yes.
Okay. Number 1 is how the enos measure the odor strength.
Okay.
Odor intensity. Let's
odor
say the odor intensity from Nelson Ng.
Okay. First, the principles of enos of enamphone actually we need experts from sniffers, we need chemists, and we need enos. First rule, we need the samples. The samples must be validated, must be verified by the experts, and then we take the sample into the chemical lab, scientific method. Then this must be validated by chemists and also experts to show that how strong is the. Based on that, we create the features. So based on that, so we quantify. So we need the sample. Samples must be validated. The strength is actually dedicated, the intensity, because the enos do not measure based like, for example, like normal parametric standardization parameter is different because based on experts on chemists from sniffers. So based on that, for example, we take a xylene case just now. we advised by we were advised by the laboratory experts. They said this is 100% xylene. So we based on that, we take that source as the pure 100% xylene. So we compare with others. So from here we have 18 data, right? From the table we have 18 data. Then from there we do the similarity indexing. Then we know which is closest to the source that we want to target. For example, we label 100% xylene is the strongest. Yeah, the strongest Odour. So which data which is closest to that xylene 100%, that is the strongest Odour. So this is the intensity. This is what is defined in intensity. So this is based on we need the samples. Okay,
that
this
means
is the first
Odour,
question.
the INOS Iamphone itself have to study about the samples first.
Yes.
Right.
And the condition is we need the experts.
Okay.
In chemists and also the panelists.
All right.
Or the expert in that area, the domain.
Okay, proceed number 2.
Okay.
Number 2, does this INOS got any certification from any third parties, like internationally and locally, from Dr. Sam Dosh?
Okay, actually we did this INOS. We working with MIMOS, right? And then before we present the MIMOS, we try to we have already presented this to SIRIM, and we fill all the documents. And after that, SIRIM said this because this device so it can be self-evaluated. We also presented to MIMOS, we said this can be self, and based on SIRIM advice, we already feel just matter to have a good industrial design and also trademark. Then we present to SIRIM. But we are working with MIMOS and also SIRIM regarding the certification. This is, and another, we have mobile. Yes, mobile for fixed. We designed the INOS based on Petronas requirement standard, PTS, Petronas technical standard. So we select the vendor who can design this one, and then there is a certified label by the certified vendors regarding the fixed one. This is for we got explosion proof box, explosion proof box. Another model. This is regarding the certification. Okay, and of course, different country have different certification, and normally they refer to European standard. And EN 13725, this also not refer to INOS, it's refer to olfactometry based on panelists. There is no such international based on Odour. Okay.
Okay. Okay. Number 3 is from Vivo 1920. I'm not sure from whom. The name not appear. So how reliable this Iamphone to
this week we classify lamb and also, sorry, not lamb, cow meat and also pork. My student go to the pork slaughtering house here in Kuantan after approval by the veterinary department. So we did, and we compare. We can differentiate. We can classify the cow meat and also pork meat. This is very academic lah. Academic. Then it's already, the report is already finished. We are going to present around 2 years ago.
maybe from the raw meat it can be differentiate or can detect.
Yes.
But if already in food already like ingredient like nasi, this nasi or plus another.
That one we need to analyze. If you have the sample, bring and then we can analyze and try to get the extract the features.
Okay, okay.
But still doable lah, doable. It's possible.
Okay, still the last question, but I have about 4 question inside. From Mr. Kamarozaman Kaneka. Applicable parameters could be test unique. Applicable parameter could be test.
Okay.
Number 2, unit of measurement. Is it ppm or whatever, percentage or whatever? Number 3, the ENOS comply with Odour regulation, which yet to establish, sampling and analysis, concentration, unit, etc. And number 4, okay, we go number 1 first. Applicable parameters could be test.
Okay, applicable parameter to be test actually Odour unit per meter per cubic meter.
Okay.
Odour unit per cubic meter. But this one is not yet established because this unit based on panelists, olfactory meter. It's not based on ENOS. Actually, if we understand how the principle of Odour unit per meter cube by doing by panelists, actually ENOS scientific than because based on panelists, for example, we have 10 panelists. The Odour unit per cubic meter, if we want to get 1 Odour unit per cubic meter, we need, for example, we have 10 panelists. We need at least 50% from the panelists. If we change and is perceived by half of the panelists. For example, 10, 5 from them of them perceive the change of the Odour, then that's what we consider 1 Odour unit, 1 Odour per cubic meter. But this one is for olfactory meter, not for ENOS. So, if ENOS, what we see actually can replace that. But this is still disagreement among scholars and also industries. But still can be, because the one that will be enacted, for example, Odour, that what I know previously they're supposed to present gazette the act, Odour Act, but still Odour Act is not gazetted, so is fall under Akta Environment, I think.
Still 20 XX 20.
Yes, still not. Tak ada lagi akta baru. No akta baru.
Okay. For number 2 from Kama, unit of measurement.
Odour unit.
Odour
per cubic meter. Yes.
Okay. Number 3, the ENOS comply. Is it comply with
okay.
Odour regulation?
Regarding the measurement.
Okay.
For Odour, there are different. We are talking about measurement. There are different type of sampling strategies. So the measurement based on strategies. For example, what we did for Xylene, we call that point source. They have another surface source, volumetric source, many others strategies. And then what we use for Xylene is point source. And for this one we call, yes, we can, for example, the air that is moving, the fluid dynamic, that we call that Odour emission rate. Different measurement, so it's different. But for one we consider static. This is constant.
Okay. Okay. Number 3, the ENOS comply with Odour regulation, which yet to establish, like sampling and analysis, concentration, unit, etc., etc.
No, not yet. Academic wise, yes, we presented to journal many academic articles, whatever is already accepted. But for standardization, there's a no Odour Act.
All right. Then number 4, last one from Mr. Kama is smart technology. Any features of ENOS, such as can connect to PC, smartphone for real-time monitoring, trading rewards, data analysis, etc.
Okay, we did IoT for our EN phone, fixed one. We try in UMP toilet to see the variation odor pattern variation in toilet. So we already log the data, and can use a laptop, PC, or also smartphone. It's already there, but we need to upgrade the features, the appearance. Okay.
All right, thank you. Okay, thank you very much already. Maybe end of our session, or still can open for the question. Is it Adin or Dr. Shafi? I think
Adin
already. Adin? Then?
Yeah, still here. Survive.
Oh, okay. Maybe we end of the session, and then maybe more question or any question for Adin and Dr. Shafi, maybe can email to me, saudin@gmail.com. saudin73@gmail.com. Sorry, saudin73@gmail.com or saudin@umpholdings.my. Okay, thank you very much for joining our webinar. The latest info will be informed later. Then any question, please email to us, and then we reply soon. Thank you very much. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam. Terima kasih, Den.
Sama-sama, jadi.
Terima kasih, Den.
Dr. Sam, thank you very much.
Baik, Abang.
Thank you.
Hassan, and Mr. Andy also, thank you very much.
Thank you.
Ya, jom. Kasih kanda.
Tak kena igak.
Kena igak boleh.
Kena igak.
Kena igak.
Ramai lagi ke dalam ni? Orang ramai lagi?
Kalau ramai lagi, demo nak on, Afif on lah, nak tanya, dia direct dia orang jawab direct, it's okay. Afif. Afif, cuba on semua. Takut ada siapa lagi nak tanya, it's okay, direct to them lah.
Melayu boleh jawab, Melayu.
Melayu, beres. Melayu orang putih lah. Bahasa Cina, Adin boleh tu.
Ni hal. Jangan tanya lebih, tu je tahu.
Kama ada soalan lebih, Ma? Cuba enable tu.
Tak boleh, dah unmute dah. Saya dah unmute all dah.
Unmute all lah.
Apa yang dia orang sendiri mute. Ada ni tinggal 14 orang.
Hassan, if any question about water, detection for chemical water in water, you can ask directly.
Okay, dah cik ni. Saya end meeting
Okay, end meeting.
Okay, nanti kita pergi balik
Okay, terima kasih. Salam.
Salam.
Terima kasih Laka.
Terima kasih semua.
Semua.